Okay, now we will do the example 16, right, which is on page 144. It says digits are selected at random from a table, table of random numbers. So digits means what we can get is 0, 1, 2 and up to 9. So single digits. And since it is from a, I mean, random, it's surely because this is, I mean, we are going to apply this. They have not told that this is uniform, but when you are taking from a table, if it is random, that means it's uniform. And also, since there are 1, 2, 3 up 10, obviously then the probabilities would be 1 over 10, right? So we will put that in a table, but now we have a trouble. This equation, right, it actually valids for it is valid for 1 comma 2 comma and up to n. So here what we have is, right, 0 comma 1 comma 2 comma and up to 9. So we have to do a little alteration for that, right? So we will assume our, now as the book says, we will say the random variable is going from 0, 1, 2 up to 9. So 1 over 9, 1 over 9, 1 over 9 and up to 1 over 9, like this, right? Whatever p what p r is equal to simple law or whatever. So this is kind of a, I mean, discrete distribution we have, but to apply this we have to convert that into a form uh, where it starts from 1, right? Now then what we are going to do is, from here to here we will define x as, right, we will define x as r plus 1, our new x. To apply this, it's r plus 1, so we will get 1, 2, 3 and up to 9, and we will get 1 over 10. Still the, because now these things we discussed, although we take a different random variable, right, the probabilities won't change. So 1 over 10, right? And so now how are we going to, we will see what's the part A they want, right? Part A, what they want is find the mean and the standard deviation. So mean is the expected value and the standard deviation equation is this. So what they want is ER, ER, right? ER. So we can equal this to expected value of what x r. So r means, now when you make r as the subject, we will get x minus 1, and that is equal to ex, right? Ex minus 1. So here we discussed this one in the other lesson. Now when we expand this, we will get the expected value of 1. Expected value of 1 is always constant, so expectation is 1. We proved that also. This is the idea. So we can put here. Now we can apply. Now n is actually now if you take, oh sorry, this goes up to 10, right? This goes up to 10, 1 over 10, right? 1 over 10, right? So I forgot that, right? So here the expect n is 10, and we can apply for this table. So ex is then n plus 1, n plus 1. So that means we will put n plus 1 over 2 minus 1. So that is equal to 10 plus 1 over 2 minus 1. So we will get, how, what is this, 11 over 5, 5.5, and it will be 4.5. We'll check the answer whether I am right. Yeah, that one is correct, right? Now we will do the part B. They are asking the variance of R. So VR, right, VR is equal to variance of x minus 1, right? Here from this we can make R as a subject, and then we get, right, now we know that also expansion I explained the variance. Now this part get vanished, so variance of x. Then we can apply this our normal equation n plus 1 into n minus 1 over 12. So now in this case the n is 10, so 10 plus 1 into 10 minus 1 over 12, so 11 into 9 over 12. So you will get an answer for this. You can put the calculator and check. So that is how you do that. I will check the answer. I mean, yeah, it's right, and it comes to 8.25. 8.25, right? Put this into the calculator and check. Actually, I did only the part A, right? So this was the table, and we use this equations to find the values for this by transforming, by using the equation what r is equal to x plus 1, right? And this is the original table. Actually, part B, they are asking something else, and I found the variance as 8.25. They are asking the standard deviation, so we have to take the square root of that, and it comes to here. So the part B is, they are asking us, right, where is the part B? Find the probability that the particular digit lies within one standard deviation of the mean. So now mean is this 4.5, right? So here also we have 8, 1 over 10, whatever. So 4.5 is around here, one standard deviation between that. So we can write like this, right? Probability, right? R lies, we'll say mean x minus, I mean we can say sigma, right, and xr, right? R x bar, here x bar, mean x bar plus sigma, right? So we have to find this. So how we are going to do that is, now x bar we found as 4.5. So the real meaning of that is 4.5, right? 4.5 minus 8.2 minus, I will write it here below, then it's easy, right? I have no space there. So P 4.5 minus 2.87 R, right, and less than again 4.5 plus 2.87. I will explain this first. I will simplify, right? Simplify, and that comes to right, one probability, right, of 1 point. Here you will get 1.63 with R, and less than 7.37. So how we are going to get that is, now the cumulative probability, right? So now from here to here, right, here to here, you have to take and subtract from here. So if this is the upper bound up to that level, right, that means I mean that idea was all right. Now here, how many, I will write it this one properly so we could take that, right? So here R will come like this. R will have values 0, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 of that, right? And all are having 1 over 10, 1 over 10, 1 over 10, right? 1 over 10, 1 over 10, 1 over 10, like that. Always 1 over 10, 1 over 10, 1 over 10, 1 over 10, right? So here now see, now how many fellows from here falls between this range. So that means from here less than 7, so 7 also falls. So here, from here to here, so all the values 2, 3, 4, 5, 6, 7 falls under this. So how many, so what we have to do is, actually this is equal, right, P 2 plus P3 plus P4 plus P5 plus P6 plus P7, right, 7. So how many are there? 1, 2, 3, 4, 5, 6. So all will have 1 over 10 plus 1 over 10 probabilities, 1 over 10, 1 over 10, right, 1 over 10, like that. So how many are there? So final answer for this is 1 over 10, so you have to add 6, so that is 6 over 10, and that is equal to 3 over 5, or in a fraction you can put 0.6. So we did the example 1, right? So I will do this question and finish off this small section, right? So exercise 6G, question 6, it says there is a spinner, right? There is a spinner, and like this, right? And there are numbers 1 to 8, right? 1 to like this, no? Right, 1 2 3 4 5 6 7 8, like this. So, and there is a pointer, right, and you turn and a number is selected, so this is like a raffle or whatever thing, right? And so we know now what are the outputs. Again, it is a discrete, evenly distributed, right? So x, you can have 1 2 3 4 5 6 7 8, right, like this you can have. And what would be the probabilities? Probabilities would be 1 over 8, 1 over 8, 1 over 8, like this, 1 over 8, right? That is the scenario. And it says x is the number of which comes out. Name a suitable model for x, right? Name a suitable model for x, right? So they are asking what is a suitable model. This model, so what is the model? Discrete, right? Discrete uniform distribution, right? Uniform distribution, so that is the model. So part A is done. Then part B, they are asking the expected value, right? So part B, expected value, ex is equal to n plus 1, right, over 2. So how many n plus 1? So here now we have to be careful, it should start from 1 and whole numbers and up to n, so it's 8. So 8 plus 1 over 2, that is 9, 4.5, very easy. And the part B, find yx. So this is all you have in this section. Part C, variance, right, variance of x. So that is n plus 1 over minus 1 over 12. So n is 8, 9 into 7 over 12, that will come to I'll put the answer now. I don't have a calculator, right? So answer is 5.25, right? And the part D, it's asking, right, will explain why a player should not expect to make money over a large number of spins. Now here in this case, to do this raffle or whatever, he has to pay £5 or $5, right? $5 or £5 or whatever he has to pay. So the expected, right, now long run, right, expected value, I mean, we can expect only 4.5. So when you someone buys that, but you can get 8 also, right? But expectation is this one. The reason, now when you take a long run means, now the answer is, in the long run this is not good, because actually this comes to this value. So always, if you keep on playing this game continuous for a long time, this is the expected value. For example, if you have head and tails in a coin, when you put 3 times, you will get 2 heads and tails. So that is kind of not balanced. Sometimes 10 times when you put, you can get 8 times head and 2 times tail. But when you put 1000 times, he can't go to 800 and 200. Roughly it falls near 500. So the the probability works when it is in a long run. So what you can say is, for this, in the long, because the expected value is less than the cost of this game or whatever, right? You can write. So do the other questions also, and if you have any questions Monday, you can ask, right? Okay.